When you are given an equation with respect to f of x, which is with respect to y, that is an explicit kind of equation. But in this video, we shall be looking at techniques of implicit differentiation. For example, let's look at this problem. X squared plus y squared equal to 9. If you have this kind of question, we can only use implicit techniques to get it done. And then the implicit techniques is that anytime you're differentiating y, it carries the symbol of the y, the x. But if you're differentiating x, it does not carry the symbol. So we end up looking for a way of making the symbol of the y, the x, the subject of the formula, and then we get our answer. It's that easy. So let's take a look at this question. The differential value of x squared is 2x. And the differential value of y squared is 2y. But this one carries the y, the x, equal to, we differentiate the constant, which is 0. And then this becomes 2y, the y, the x, equal to, we move 2x to the other side of equality sign. And of course, it is plus 2x here. It changes to negative 2x on the other side of equality sign. And then we make this the subject. And this becomes the y, the x, equal to, we divide both side by 2y. This becomes 2x over 2y. So this can still get rid of this. So finally, we have the y, the x, is equal to minus x over y. So that is how we can differentiate x squared plus y squared equal to 9 as a question. Let's look at another problem. Let's say we have x squared y plus x y squared equal to 3x. So the question is to find the y, the x. So we are differentiating the x part of x squared y. And this gives us 2x multiplied by y. And plus, we need to differentiate the y part of x squared y. So differentiating the y part, it simply gives us x squared. So when you differentiate y, and of course it's going to be 1, but because we're differentiating y, it carries the symbol of the y, the x. And then plus, we differentiate the x part, and of course, we simply have, differentiating the x part here, we simply have, that's going to be 1 multiplied by y squared. So this gives us y squared. And then differentiating the y part here, this is going to give us plus 2xy, because this is 2 times x, then y raised to the power 2 minus 1, which is y. That's how we obtain this. And then it has to carry this symbol of the y, the x, equal to, then we differentiate 3x. Differentiating 3x will simply give us 3. And then we try to combine the ones with symbol of the y, the x, move it together. And therefore this becomes x squared, the y, the x, plus 2xy, the y, the x, and then we still have this one left there, 2xy, and then we have plus y squared equal to 3. So we try to move all of these to the other side of equality sign. So that, and at the same time, we can just go straight and make use of the y, the x to factorize what we have there. So this becomes the y, the x, in a bracket. This is going to be x squared plus 2xy, okay, is equal to 3. This to the other side becomes minus 2xy. This to the other side becomes minus y squared. And of course, we divide both sides by the coefficient of this symbol of the y, the x. So if you divide everything, both sides by everything we have here, this becomes the y, the x equal to 3 minus 2xy minus y squared. Everything over x squared plus 2xy. So that is how we can differentiate such a question with implicit techniques. Let's take a look at another problem. Here we have, this is another problem, x cubed plus y cubed is equal to 8. Okay, so we're to find the y, the x. So finding the y, the x, we're simply differentiating x squared. That's going to give us 3x squared. So differentiating y cubed here is giving us 3y squared. But this one needs to carry the y, the x, because it is y we're differentiating. And then differentiating the constant is going to be 0. And then we try to make the y, the x the subject of the formula. So we have 3y squared, and then the y, the x equal to this to the other side of equality sign. It becomes negative 3x squared. And of course, we divide both sides by 3y squared. So this is the y, the x equal to negative 3x squared, everything over 3y squared. So this gets rid of this, and therefore a final answer for that question of the y, the x can be negative x squared over y squared. So that is the answer to that question. So let's take a look at another problem there. Let's say we have x squared plus 2xy plus y squared equal to 5. The question here is to find the y, the x, like we did on the previous examples. So we differentiate each of these terms that we have here. Differentiating x is going to be 2x. Differentiating the x part of this place is going to give us 2y. Okay, plus we need to differentiate the y part of this term here. is going to give us 2x. But because it is y we differentiated this time around, it carries the symbol of the y, the x. And then plus, we are differentiating y squared here. And of course, it has to be 2y. And it has to carry the symbol of the y, the x, equal to, then we differentiate a constant, which is going to be 0. And therefore, we try to bring all of this to the other side of equality sign. So this becomes 2x, the y, the x, plus 2y, the y, the x, equal to then 2x to the other side. That becomes minus 2x. And 2y to the other side. That becomes minus 2y. And of course, we use the y, the x to factorize this place. And this becomes the y, the x, in a bracket 2x plus 2y equal to, and of course we can simply use minus 2 to factorize this. So if you use minus 2 here, this becomes x plus y, and then we divide both sides by the coefficient of the y, the x here. So that becomes the y, the x, equal to, this is minus 2 in a bracket x plus y, everything over 2x plus 2y. And of course, when you take a look at the denominator, we can still use 2 to factorize both x and y there. So finally we have the y, the x can be negative 2x plus y, everything over 2 in the bracket x plus y as well. And of course, they both cancel out. So this can get rid of this can get rid of this. So finally, our the y, the x can just be equal to negative 1. This 1, this 1. So negative times 1. And then we have minus 1 as our answer. Here is another question. This is 5xy minus y cubed equal to 8. So we need to differentiate 5xy minus y cubed equal to 8. So we have to find the y, the x. So finding the y, the x, we use the techniques of implicit differentiation. So we need to first of all differentiate the x part here. Differentiating the x part, of course, is going to give us 5 times the differential value of x raised to the power of 1 is 1, and then multiplied by y. So it's giving us 5y. Plus, we need to differentiate the y part here. Differentiating y here is still going to give us 1, then 5x times 1 is still 5x. So it's 5x. Then because it is y we differentiated it, so it carries the symbol of the y, the x, minus, of course, differentiating y cubed. That gives us 3y squared. Of course, it has to carry the y, the x, equal to the differential value of a constant number is going to give us 0. And then we can actually make use of the y, the x to factorize this term and this term. Why we move these to the other side of equality sign? So we have 5x, the y, the x, minus 3y squared, the y, the x, the x, equal to minus 5y. And therefore, if you use the y, the x to factorize this, so we have the y, the x, in the bracket 5y minus 3y squared equal to negative 5y. And of course, we can just divide both sides by 5x minus 3y squared, which is the coefficient of this symbol of the y, the x. So the y, the x in this case becomes minus 5y, everything over 5x minus 3y squared. So that is the answer to such a problem. So let's take a look at another example here. Okay, let's take a look at another problem. Let's say we have to differentiate tan xy equal to 7. So if you have to differentiate tan xy equal to 7, okay, this is what we do. You know, the differential value of tan theta is sec squared theta. So xy is our theta here, or just any of the dummy variables. Okay, so this is tan xy. So the differential value of tan xy there is going to be sec squared theta, which is sec squared xy in this case. And then multiply that, we're going to make use of chain rule there. So we need to differentiate the content of the bracket. So differentiating x alone is simply going to give us y, okay, plus differentiating y, that's going to give us x, okay. Of course, because we're differentiating y, we're going to have the y, the x attached to that, okay, equal to, we need to differentiate this symbol, this number of 7. So differential value of a constant is going to be 0. And then we can simply do this like y plus x, the y, the x, and the bracket, and then dividing both sides by sec squared xy. Since this one looks like as the coefficient of everything you have there, so this is going to be 0 divided by sec squared xy. Or I can still choose to write this for a better understanding. Okay, divide both sides by sec squared xy, so that this cancels, so that what we have eventually becomes y plus x, the y, the x, equal to 0, because 0 divided by any number is going to be 0. So we need to move y to the other side. So this becomes the y, the x, equal to 0 minus y. So, permit me, we have x there, and therefore our the y, the x, is equal to 0 minus y becomes minus y over, we need to divide both sides by x divided by x. So that is the answer to such a problem. Okay, so let's take a look at another problem. Here is 36 equal to the square root of x squared plus y squared. Of course, we can just, this one can be expressed as 36 squared equal to x squared plus y squared when you scale both sides. And therefore, we can rewrite it this way: x squared plus y squared equal to 36 squared. Okay, 36 squared will still give you a constant number when you want to differentiate it. So differentiating x squared here will give us 2x, plus differentiating y squared will give us 2y, but it has to carry the symbol of the y, the x. And differentiating a constant is going to be 0. So we have 2y, the y, the x equal to, moving this to the other side of equality sign, that becomes minus 2x. And therefore, our the y, the x equal to minus 2x over 2y. This happens when you divide both sides by 2y, which is the coefficient of the y, the x here. And therefore, the y, the x here equal to this, get rid of that. So the answer becomes negative x over y. So that is the answer to such a problem. Kindly subscribe to my YouTube channels. Thank you.